Hello students, welcome to All Force e-learning channel. This is K. Nageshwar Rao, your physics faculty. Today we are dealing with session number 37, first year Neet, session number 37. And today we'll continue our discussion connected with the graphs, and we'll try to solve few problems. Let us quickly recollect what has been completed so far relevant to graphs. Okay. If at all, if a body is moving with uniform motion in the sense if it is moving with constant velocity, this is a graph what we have seen, isn't it? It's a straight line parallel to time axis. Corresponding position time plot is this one. What is this? This is also a straight line passing through the origin, isn't it? And if the body is moving with uniform acceleration with a constant acceleration, and this is the graph, velocity time graph, it will be a straight line passing through the origin, and corresponding position time plot is this one. You will have a curve something like this with the increasing slope, okay. And in this case, let us say the initial velocity is 0, then only the graph has started from the origin in this case, isn't it? What if the body has some initial velocity, some non-zero value of velocity? This is the graph, okay. It starts at some point on the velocity axis like this, and corresponding position time plot is this one. Whatever curve you are having, again this is also what a curve with increasing slope. I am talking about increasing slope because slope of position time plot graph gives us velocity, isn't it? So here it is also having what? Increasing slope, isn't it? And now if the body is undergoing uniformly accelerated motion with some initial displacement, then graph remains as it is, but corresponding position time plot will be something like this. It starts at somewhere at a point on the y-axis, at a point on the displacement axis, okay. And similarly, if the body is undergoing uniformly retarded motion, this is the velocity time graph. You will have a negative slope, a straight line will be there, okay, and corresponding position time plot is this one. And if you observe this graph, see what is happening to the slope of the graph. It is decreasing, and finally it is becoming 0. If the slope becomes 0, what has happened to the velocity? Velocity has become 0, isn't it? That's what the physical significance of position time plot. What if the body is undergoing uniformly retardation motion? Uniformly it is undergoing retardation, and it has started undergoing acceleration in the opposite direction. Then what happens? You will have a line with a negative slope, but after intersecting with the time axis, what is happening? It is going into the fourth quadrant, isn't it? And corresponding position time plot is this. What has happened in this position time plot? Initially the slope has is decreasing, and later slope is increasing. Okay, so these are the details about the graphs. Okay, so let us continue with the further discussion. Okay, well, so so far whatever graphs related discussion we have carried in the previous sessions, that discussion was involving position time plot as well as velocity time plot. We haven't discussed about acceleration time plot, isn't it? So let us discuss about acceleration time plot, because there is one important significance connected with that. So if AT graph, let us say the body is moving with uniform acceleration, okay. Let the body is moving with uniform acceleration. Uniform acceleration in the sense constant acceleration. So this is our acceleration, which is taken on the y-axis, and I am taking time on the x-axis. Okay, if it is having a constant acceleration, well, what you will have? You will have a straight line, isn't it? At time t equal to 0, let us say it has some acceleration a1. Okay, as the clock is ticking, there is no any change in the acceleration. Again, the point is same, a1. Again, it is same. Again, it is same. When you join all these points, what you will get? You will get a straight line parallel to the time axis. Okay, so this is the graph, something that gives us uniformly accelerated motion, isn't it? So if a body is undergoing uniformly accelerated motion, you will have a straight line parallel to time axis. Now I'll call this as a1. Corresponding to this final point, I'll call the time as t1. Okay, let me calculate the area under this graph. Area area under the graph is equal to what? A1 into T1. Is that right? So this particular length of this shape is what? A1. This particular length of this shape can be taken as T1, or length and breadth. Okay, A1 into T1. What is this? Acceleration multiplied with the time. See, acceleration, mathematically it is expressed as velocity by time. So when you take acceleration product with the time, what you will get? You will get velocity, isn't it? So this can be written as velocity. So this is what makes our physical significance. Whatever area we are calculating under acceleration time graph, that gives us information about velocity of the body. Okay, so I want you to remember this. What is the physical significance of acceleration time graph? If you calculate area under acceleration time graph, what you are going to get? You are going to get velocity. The other possible things we can think, like acceleration, sometimes it may not be uniform. If it is not uniform, what we call, if it is changing with the time, if it is changing with the time, we call it as jerky motion, isn't it? So something that we least bothered about, okay, in the present discussion. So this is what information we need, okay, to pursue problems, numerical problems. Okay, so remember this point, and I'll continue with few numerical problems now. Okay. Now let us discuss this first question. Okay, this is something connected with the graphs related information. The question is, the following figures shows velocity v versus time t curves, but only some of these can be realized in practice. These are, so here 4 graphs are given, all are velocity time graphs only. Okay, and what we have to identify? We have to identify those graphs which are practically possible. All the graphs may not be possible, right? Whether they are possible or not, we have to check conceptually, and whatever physical significances we know, related to these velocity time graphs, we have to make use of those things, and we have to identify which is actually possible, in practice. In practice, in the sense, practically it should be possible. Okay. So let us first try to analyze this one. Here, what is happening? As the time is increasing, the velocity is increasing, something which is possible. Yes. Okay, and then after reaching certain velocity, what is happening? The velocity is decreasing. So the body started undergoing deceleration. Okay, now after reaching certain time, what has happened? Velocity remained constant for a while. For some time, velocity was constant, and then again, velocity started increasing. Up to here, there is no problem. All these situations are possible. But after reaching this point, what is happening? See, you are having a straight line. If you are having a straight line, what does it mean? If you calculate slope of velocity time graph, what you will get? You will get acceleration, isn't it? Slope of velocity time graph gives us acceleration. Area under velocity time graph gives us displacement. These are the two physical significances connected with velocity time graph. Here, I'll make use of this slope concept. Okay, when you take the slope of this straight line, what you will get? You will get infinite, isn't it? It means acceleration is infinite. Is it possible practically? No, it's not possible. So this graph, here, okay, again, but again here there is a straight line. So those straight lines, vertical lines, parallel to velocity axis, they indicate that the slope is maximum, infinity. Slope is infinity in the sense acceleration is infinity. Okay, something which is impossible practically. So this graph is not possible. Okay, now let us have a look at the second one. Here what is happening? Velocity is decreasing. Okay, it's not uniform variation in the velocity. Here if you are having a straight line, what do you say? You say that body is undergoing uniformly accelerated motion. Here the curves indicates that velocity is not changing uniformly. So here it is decreasing, and again it is increasing, and again it is decreasing, and it has become 0, and after this, the velocity has become negative. It means the body is traveling in the opposite direction. So again, when the velocity is negative, it is also increasing, and again it is decreasing, and again velocity has become positive. So this kind of situation is practically possible. Okay, so this graph is possible. So let us analyze these two curves also. Might be, 1 or 2 curves or 3 curves might be possible. Let us have a look at this one, third one. As the time is increasing, what is happening to the velocity? Velocity is increasing, isn't it? Up to here, it's fine, but look at this part of the graph. Corresponding to a particular time, 2 velocities are possible. Let us say this is time t naught. Corresponding to time t naught, here one velocity is possible, here another velocity is possible, something which is practically not possible. At a given time, the body possesses only one velocity, isn't it? So this graph is also practically not possible. Let us have a look at the fourth one. Here, yeah, it's possible. Velocity is increasing and again decreasing, again increasing, again decreasing, like this. Okay, so this is something practically possible. So here, what are the two graphs which are practically possible? The second one and fourth one. These two graphs are possible, and these two graphs are not possible. Okay, so this is how you have to make an analysis when you look at the graphs, and you have to identify which graph is practically possible, which is not possible. And for identifying which is possible, which is not possible, which graphs are not possible, you have to make use of conceptual details and physical significances connected with the graphs. Now let us solve one more question connected with the graphs. Okay, now let us discuss about this question. This is a very basic question. So far in the previous sessions also I did not quote such kind of questions, so that to give you an idea I have picked up this question. This is a very simple question. Let me read this. The velocity time graph of a body moving in a straight line is shown in the figure. The displacement and the distance travelled by the body in 6 seconds are respectively. This is the graph given. So if you wanted to find out the displacement from velocity time graph, what you have to do, you have to calculate area under the graph. And here he is asking about displacement as well as distance. The body is travelling along straight line only. If without turning back, if the body continuously travels along the same direction, then displacement and distance both will be same. But this particular part of the graph, which is in the fourth quadrant, which is showing a negative velocity, it indicates that body has turned back, and then again it had turned back and it is traveling in the forward direction. Like it is traveling from left to right. After traveling certain distance, it had turned back, and after traveling certain distance, again it turned back and it went ahead. So that's that kind of situation it is. Okay, so let us try to find out the area first. Okay, whatever area I will be calculating here and here, those areas will give us displacement, positive displacement, and I am going to subtract this area from these two areas, then I will get the total displacement, isn't it? Because this thing particularly gives negative displacement. Okay, so let us first calculate the area. Since area under VT graph gives displacement, total displacement is equal to, what is the area of this box? From here to here it is 4 units, from here to here 2 units, 2 4s are 8, and this one from here to here 2 units, and from here to here also 2 units, 2 2s are 4, but what is this? This is a negative displacement minus what you have to write, 4, and this is again positive displacement, 2 units, 2 units, isn't it? This is equal to 2 units, this is equal to 2 units, so 2 2s are 4 plus 4 equal to how much? 8 meters. Okay, so here the total displacement of the body is equal to 8 meters. When it comes to the distance part, distance has no sign. Whatever the entire path length is covered by the object, you have to add all those things. So when it comes to the distance, you will be adding all the areas, whether it is here or here, whatever it is, the total area will be added. This area plus this area plus this area. How much is that? 8 plus 4 plus 4, 16 meters. So the total distance covered by the body is equal to 16 meters, and the displacement of the body is equal to 8 meters. Okay, so this is that simple. Just remember, whenever you are given with such kind of questions, you will see questions in the material, you will have graphs like this, something like this. Okay, if you are having graphs like this, you have to divide this entire area into different regular shapes. This is a triangle, this is a rectangle. Here also you can make bifurcation. Here this is a rectangle, sorry, this is a triangle, this is a rectangle. So you can find out corresponding areas. Okay, and you can talk about the total displacement and total distance covered. Okay, so now let us discuss about one more problem. Now let us discuss about this problem. What is this? The displacement x of a particle of mass m, which is given in kgs, here displacement is in meters, moving in one dimension under the action of a force, is related to time t by t equal to under root x plus 3. the displacement of the particle when its velocity is 0 will be. So we have to find out the displacement of the particle when finally velocity becomes 0. But the question is, we don't know when velocity is going to become 0. At what time velocity is going to become 0, we don't know that. Okay. So let us make use of whatever equation he has given. Okay. Given that t is equal to under root x plus 3. If I wanted to write expression for velocity, what I have to do? I need to have an equation for displacement in terms of time. Then I can differentiate that. Dx by dt will give us velocity. Okay, so I will shuffle this equation. Under root x equal to t minus 3. So x equal to t minus 3 whole square. Okay, since Neet people are, most of the people, they find it a little difficult with the differentiation. So I'll try to make it simple. I will elaborate this one. T square, in fact here itself directly you can write it 2 of t minus 3, but let me write t square plus plus 9 minus 6t. Okay, this is what x is. Now I will differentiate on both the sides. Dx by dt is equal to d by dt of t square is what? 2t. D by dt of any constant is 0 minus d by dt of 6t is 6. Since d by dt of t power n is equal to n into t power n minus 1. Using this formula I have written this one, right? And what this dx by dt is? It's velocity. Velocity is equal to 2t minus 6. So what he is talking about, what condition he is talking about? He is talking about velocity becoming 0. At that time we have to find out the displacement. So let v equal to 0. If v equal to 0, 2t minus 6 equal to 0. Therefore t is equal to 6 by 2, which is 3. So after a time equal to 3 seconds, what is happening to the velocity? Velocity is becoming 0. And now what is displacement here? Displacement is x equal to t minus 3 whole square, isn't it? So now I am going to replace t with 3. Since x equal to t minus 3 whole square, and at a t equal to 3 seconds, what is the displacement? It's 0. So the displacement of the object is 0. So that's how you are supposed to handle these kind of questions. Okay. So you need to remember the basic formula connected with the differentiation and integration to handle questions. In the previous NEET examinations, questions based on these kind of approaches, based on these kind of mathematical tools, questions were given. Okay. So let us continue with one more problem. Now let us discuss about one more question. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to v of x. Velocity is given as function of displacement, isn't it? Function of position of the particle. V of x is equal to beta into x power minus 2n, x power minus 2n, where beta and n are constants and x is the position of the particle. The acceleration of the particle as a function of x is given by. So here velocity is given as a function of x, and we have to find out acceleration as a function of x. This is also one of the question from previous medical entrance examination. Okay, let us try to write expression for acceleration in terms of x. Given that v of x equal to beta into x power minus 2n. Okay, I am going to make use of this formula. D by dx of x power n is equal to n into x power n minus 1. Okay, so here first I will find out acceleration. Acceleration a can be written as dv by, okay, actually if it is a function of time t, we can find out dv by dt, but here v is not given as a function of time t. So what I am going to do is I will take dv by dx. If dv by dx is taken, okay, so what you are going to write? X power, in place of n, what do we have? We have minus 2n, isn't it? So n into x power n minus 1 minus 2n into x power minus 2n minus 1. Okay, so this is what dv by dx is, and I am going to make a mathematical manipulation here. This can be written as dv by dt into dt by dx, which is equal to beta into minus 2n into x power minus 2n minus 1. Okay, so here dt dt gets cancelled, you will have dv by dx. You can make such kind of mathematical manipulations. Okay, so now dv by dt is what? Acceleration, and dt by dx is what? Inverse of velocity. Velocity is expressed as dx by dt, isn't it? Inverse of dx by dt is what? Dt by dx. So here you will have velocity v at the bottom. is equal to minus 2n beta into x power minus 2n minus 1. Therefore, acceleration is equal to velocity into minus velocity into 2n beta x power minus 2n minus 1. What is v? It is already given, beta into minus beta into x power minus 2n into 2n beta x power minus 2n minus 1. Now, finally, you can shuffle this like this, beta square into 2n into x power minus 2n into x power minus 2n minus 1 is x power minus 4n minus 1. Okay, so this is what the acceleration, and here acceleration is what? Function of x. Beta and n are constants. So this is how you can express acceleration. Okay, so let us solve one more question. This is the question. This is also from previous NEET exam only. If the velocity of the particle is v equal to at plus bt square, where a and b are constants, then the distance travelled by it between 1 second and 2 seconds is. See, in the previous two questions we have used differentiation, okay, one mathematical tool, that is one mathematical tool, and here you have to go with integration. I'll tell you what that is first. Okay, you can express like this, integral x power n dx can be written as x power n plus 1 by n plus 1. See, being a NEET aspirant, your worry should be always regarding, whenever we inform about mathematical tools, you always should think about, how to make use of these mathematical tools in physics. Okay, so don't worry much about its background, how it is derived, okay, what is its history, such kind of details are not necessary. Okay, for you guys, you can restrict your understanding up to what? How to make use of these equations, these formulae in physics. So that's what our primary concern should be. So here I'll take x1 and here I will take x2. Okay, and I'll call those two things as limits, x1 to x2. This is called as a lower limit and this is called as upper limit. Okay, so integral x power n dx is what? X power n plus 1 by n plus 1. After writing this, I have to apply these limits. I will write lower limit here, upper limit there. Let us replace x with x2 n plus 1 by n plus 1 minus replace x with x1 n plus 1 by n plus 1. This is what you should remember. Okay, so if any function is given, you have to, if you are supposed to integrate that, you have to write that function here, and with respect to what you are integrating, with respect to x you are integrating, and this is the formula which is frequently used to deal with the integration tool in physics. So integral x power n dx can be written as x power n plus 1 by n plus 1. If limits are there, limits here, what are the limits? He is asking us to consider the distance travelled between 1 second and 2 seconds. Maybe after 2 seconds also the body might be moving. But he is not asking about the distance covered after 2 seconds or distance covered by the body before 1 second. He is asking about distance covered between these two limits, 1 second to 2 seconds. So here lower limit is what? 1 second. Upper limit is what? 2 seconds. Okay. So, after writing this formula, what you have to do? First you have to substitute upper limit minus, then substitute lower limit. So that's how you can make use of this integration mathematical tool. So let us solve this question. What is given? Given P is equal to at plus bt square. Okay, and both a and b are given as constants. So what we have to find out? We have to find out the distance travelled between 1 second and 2 seconds. Now I am going to modify this v. I can write this as dx by dt, isn't it? Is equal to at plus bt square. Let me separate the terms. It can be written as dx equal to at plus bt square into dt. Now let me take integration on both the sides. Integrating on both the sides, but you will have integral dx. Remember children, integral dx is equal to x. In fact, this integral dx is written as integral 1 into x. 1 can be written as x power 0, x power 0 dx is what? X power 0 plus 1 by 0 plus 1. X power 0 plus 1 is x. So finally integral dx comes out to be as x. Integral dx is x, integral dy is y, integral dt is t. So here integral dx is what? X equal to, and this x in the present scenario, what it represents? It represents distance. And I am not worried about the total distance. I am worried about distance covered by the object between what limits? 1 second and 2 seconds. And I'll integrate this one, at plus bt square into dt. Okay, so if I integrate this one using the formula, what I will get? At square by 2 t power 1. In place of n you have 1, x power 1 plus 1 by 1 plus 1, x square by 2. So here what you have? Integral t into dt, t square by 2. That's what you will get. Plus similarly here, what you will have? T cube by 3. After integrating, you have to apply these limits 1 to 2. Let me substitute 2 first. A into 2 2s are 4 by 2 plus b into 2 cube 8 by 3 minus, substitute lower limit, a 1 square by 2 plus, substitute 1 here, you will have b by 3. So when you are taking minus sign, here also you will get minus sign. Okay, so let us simplify this. X is equal to 2a, and here what you have? Minus a by 2. Next plus 8b by 3, 8b by 3 minus b by 3. So 2a minus a by 2, what you will have? 3a by 2 plus, here you will have 7b by 3. So this is what the distance traveled by the body between 1 second and 2 seconds. Okay, so that's how you are supposed to handle the problems. Okay, so whatever questions are discussed today, most of the questions are from previous examination. Okay, so in the next coming sessions we will continue with the motion under gravity. Thank you, students.